Good evening everyone. In this video, we can discuss about deadlock avoidance. So under the banker's algorithm, the resource request algorithm. So how the each and every process giving the request, whether the request is valid request or not. So the resource request algorithm help us to check this thing. So the algorithm is determining whether the request will be valid as well as whether we can able to grant that kind of the request or not. So the request of I, that is any one process, it's giving a request. So from each and every type of the resources, how many instance it's need. So that is the specification of request. Here the request of I, the process I or thread I, it is indicating the type of J resources. So I need K instances. So K is the number of resources. So this is a resource request algorithm. So once the request is given, so first condition we need to check whether the request is less than or equal to their need. So the need is nothing but the safety algorithm we find max minus allocation. Maximum is their eligible criteria after allocating further how much it needs. So that must be the request must be less than or equal to their need. And second condition, our request must be less than or equal to our available resources. If both the conditions satisfy, then only we can able to allot the resources. Otherwise, the process can't able to proceed. So the process must be in a waiting stage. Once these conditions are valid, so then the process will execute and it needs to modify the following three states. So we have to update the value of available resources. From the available, we are reducing the request of which process giving the request. So that much resource we allotted to that kind of process. So we are reducing the available resources. Then allocation of I plus request of I. So which process? The process 1 is giving the requestments. So for that corresponding process, the allocation is going to be increased. Then the corresponding process need. So the need is also going to be reduced. The need equal to need minus request. Now we can solve this problem based on this given scenario. So the allocation matrix given, max matrix given, available information. At this stage, the system is working in a safe state. Now, the thread 1 giving the additional one instance of resource type A and the two instance of resource type C. So like that, the thread was giving the request. So now we need to validate this request is valid request or not. If it is valid, we are just giving the grant to execute. After the execution, so the values must be updated. So the now request of 1 equal to, for the A type it is asking one instance, so 1. B type it is not asking anything, so 0. Under the C type it is requesting 2 instances, so 2. So the request of thread 1 is 102. So now as per the algorithm we need to solve. So the first condition is the request must be less than or equal to our need. So the request of 1 must be less than or equal to need of 1. So what is the need matrix? So the previously we identified, again the same method, need equal to max minus allocation. So the need matrix A, B, C, 4, 0, 2. So max minus allocation is 7, 4, 3 and 1, 2, 2, 6, 0, 0 and 0, 1, 1 and finally 4, 3, 1. So now need of 1 is 1, 2, 2. The request of 1 is 1, 0, 2 is not equal to 1, 2, 2. So the 1 equal and 0 is less than and 2 is equal. The condition satisfied. So the first condition satisfied, and second one, the request of 1 must be less than or equal to our available resources. So 1, 0, 2 less than or equal to our available is 3, 3, 2. Yes, here also condition satisfied. So both the conditions satisfied means, so we need to update the values. That is the third step. What is available equal to available minus request of I. So here the request of 1. So what is our available? 332. From this we are allotting some resources to the thread 1. So what it requested? So what is its request? 102. So this much of the resources we allotted to the thread 1. So now our available resources is going to be reduced. So available equal to 230. And then the next one, allocation of I equal to allocation of I plus request of I. That is, here I is 1. Allocation of 1 equal to allocation of 1 plus request 1. So what the thread is requested, it is allotted now. So the allocation, it is going to be increased. So allocation of 1 is initially 200 plus the request is 102. So now the allocation of 1 become 302. So now allocation of thread 1 is updated, our available resources updated, and then finally the need of 1 equal to need 1 minus request 1. So the need 1 we already found in previous 122. The need 1 is 122 minus the request 1 is 102. So the need 1 equal to 0 to 0. So this is the updated value. So now the given request is valid request. So the thread 1 can able to execute. After the execution, so these are all the values are getting updated. So in this matrix, so the allocation will be changed, and again the available will be changed, and then need matrix is going to be getting changed with this updated value. So now again we need to check with the safety algorithm after this updation whether the system is in a safe state or not. So thanks for watching this video. We will see in your next session.